class yesterday, so she said she was just
Okay, so on today, what we're going to do is we're going to do section 3, day 2. I'm going to teach you or show you another way of dividing this. Yesterday we did long division just like you did way back when you were a kid. Long division will work for every problem that I give you. Okay, that's the one thing that you're gonna know about this is long division will work for every single problem that we have. The new way that we're going to go through is called synthetic division. With synthetic division, this only works if the divisor, do you remember which one the divisor was? The one on the outside or the one that on the bottom or to the right, okay, is linear. What do I mean by the word linear? I mean like x plus 3, x minus 5. It cannot be x squared, blah, 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 being on the outside. If it's x squared or higher on the outside of the square root, or not square root, of the divide symbol, then we have an issue. We can't use synthetic division. Synthetic division only works if it's like x plus a number or x minus a number. There's no squared in the divisor. Squaring in the divisor does not work for synthetic division. Linear only means I can use synthetic division. Synthetic division only works if the divisor is linear. I don't know why I'm saying that about 5 times, but I hope it's sinking in. Synthetic division will only work when the divisor is linear. Okay? So, the problems are going to look just like you had yesterday. It's just we're going to do a different technique with it. Okay? So, does this look like yesterday's?
Yep.
Yeah, everything about it's the same. Now, is the divisor linear? Yes. How do you know, what does it mean when it's linear? Doesn't have an exponent, so it's x minus 3. Awesome. What I want you to do, the first step, is take the divisor, set it equal to 0, and solve for x. So, what is x minus 3 equals 0? What is x? If I add 3 to both sides, I get x equals 3. Good. That's awesome. That's the number we're going to use. Now, what we're going to do is, and I write mine a little bit differently than the way your book shows it, but it's the same concept, where I'm going to put 3 in a backwards L. This, by the way, is 1 line of paper. 2 lines of paper, just like that. Okay, so that's like my lined paper that you guys use. Now, on the same line as where the 3 is, I want you to tell me what the coefficients are from the dividend, from the front stuff. What's the lead coefficient? -1. Now I want you to leave a space. What's the next coefficient? 4. Then I want you to leave a space. What's the next coefficient? What?
None.
No. 0. What's the next number after 0 then? 9. Now, again, it is important that if you're missing a group, see how it goes 3, 2, constant? It's missing the x to the first term. So therefore, that had to be a 0 in there. Just like Edie was gone yesterday, we missed you so much. So therefore, we saved your spot for you. Nobody sat there. So it's the same concept, we're saving that spot. Is everybody okay with getting the numbers set up? Now, this is going to go really, really quickly. It's going to save you a ton of time and paper. Promise. The first number you drop straight down as if somebody were swimming in a pool and dropping to the bottom. This guy can't swim. So therefore, I drop straight to the bottom. Okay? So you drop the first number straight to the bottom. Is everybody okay with that? Okay, now I'm going to color code this for you guys so that you can see what's happening. Now I want you to take the number that was in the backwards L and multiply it by the number down there. What's 3 times negative 1? Negative 3. You're going to insert that answer underneath the next number. And then you're going to add straight down. What's 4 minus 3? 1. Now you're going to repeat the process until you get all the way through. So what's the next thing that I have to do you think? Multiply it by 3 and the 1. So I got to do this again. What's 1 times 3? Takes me longer to color it. And then add straight down. What's 0 plus 3? 3. And then one more time. 3 times 3? 9. 9 plus 9? 18. Awesome. Now, it's time to put the letters back in. Notice the one thing about this technique. Did I use any letters yet?
No.
So here's what happened. You had a dividend that had a highest exponent of 3, yeah? The front stuff had an highest exponent of 3. And you're dividing it by something that had a 1. You remember exponent rules? If you have 3 on top and 1 on the bottom, you subtract them. Right? When you're dividing, you subtract exponents. So what's 3 minus 1? So guess what exponent I start with? 2. So this is negative x squared plus 1x plus 3. And what do you think the last number is? Well, I know it's 18, but what is it in our problems? What did we talk about yesterday was the last thing? The remainder. Plus 18 over x minus 3. Now, the alternative is we could have long divided it, and guess what we would have got? Same answer. Guess how much paper we would have taken up by doing that? About a half a sheet. For some of you, maybe a full sheet because you write too big. But we just used about, what, 4 lines? Why is it x squared? Because, again, the highest exponent was 3, Taylor. And the bottom exponent, like if I'm dividing, would be a 1. So when you do exponent rules, way back in the day when we had something like x to the third over x to the first, you subtracted the exponents. That's the division rule. So 3 minus 1 is 2. So you start with 1 less all the time. So if the highest exponent would have been a 5, I start with a 4 and then work my way through. What's the last number always? The remainder. Okay, let me show you another one. All right. Can I do this one using synthetic division? Yes. Why? Okay. The divisor's linear. Good. So what number goes in my backwards L? 1. What numbers go across for the coefficients? 3. Negative 7. Don't forget the signs. They go with it. 6 and 8. Notice how I left space in between there? Do you know why I leave a little bit of space? So I can go underneath it. The other thing is, if I put them too close together, could that potentially look like 3 and negative 768? So that's why you leave a little bit of space when you're doing it. What's the process? What's the first thing that needs to happen?
Bring 1 down.
Bring the 3 straight down. Multiply, which is 3. Insert add. Multiply, insert, add. Multiply, insert, add. 10. 8 plus 2. Okay? What do you guys think? Now, what is the highest exponent we're going to start with? It had a 3, but now I've divided 1 away, so now it's going to be x squared. Right? 3x squared minus 4x plus 2. And what's the 10 again? 10 over x minus 1. Done. Now, the question that comes out of most people, because I do this in college algebra also, they say, why don't you show us this first? Okay? This only works if the divisor is linear. Long division works for every single one of them. Most of the ones that we have, some of them aren't linear. So it's better to show you guys the one process that works for every single one of them, rather than one that only works for certain ones. The ones you're going to have today are going to be synthetic divided. They should be anyway. Do you want to do another one like this? No. Okay. The last thing that you are going to have, though, or are going to see, is it's going to say this. Use synthetic division to evaluate the function for the indicated value of x. And here's what it wants you to do. If I gave you something like this, it said f of x equals 5x to the third minus x squared plus 13x plus 29, and I said f of negative 4, in your past history, what would you do for this problem? Plug in negative 4 in for x and see what you get. Right? Okay? So, could you readily do that on a calculator, for instance? Absolutely. Okay? And somebody do that. Hunter, are you typing it? Okay. Ugh. What'd you get?
Negative 261.
Okay, hold on. Did I multiply that right? 4 times 7, carry the 2, 38.
4 times 7 is 28.
Right, and then carry the 2, and then 4 times 9 is 36, plus 2 is 38. So I've got this right so far. 29 minus 388, negative.
That's what I want.
Then you got that, and you typed it in with the calculator, and I got negative 359 here too. Awesome. One of the things that we have with synthetic division, and this was a big number, that's why it took a little bit more time, but a lot of times the numbers are a lot smaller than that. This is called the remainder theorem. And the remainder theorem is something, remember in geometry last year you guys had a lot of theorems? What are theorems? Things that were proven to work. Right? That's what a theorem is. Things that you can prove that work. A remainder theorem says this. You can plug the number in, just like Savannah did over here, into your calculator and see what comes out. Or you can use synthetic division, and the remainder is the answer. Okay? So what I did was I did synthetic division, and I got the same answer that Savannah got by plugging it into her calculator in almost the same amount of time. Now, typically those numbers are a lot smaller. That's why and a little more user-friendly, but that was one that I found in here. But a lot of times, I know in my college algebra textbook, they're a lot smaller numbers. It goes really fast, and all of a sudden I'm done way before they are even taking their calculators out. Okay, so it's just another tool. They're going to ask you to synthetic divide it. Now, here's the nice thing about this problem. It says in the directions for this, use synthetic division to evaluate. So all you have to do is use synthetic division and circle the remainder. You do not need to put the x's back in. When it says to evaluate it using synthetic division, you just circle the remainder and you're done. You do not need to put it back in with the letters. The first half of your assignment, you're going to do like we did the first two, where you got to put the letters back in. The second half of your assignment is going to be this, where you just circle the remainder. You guys should be done with it in about 10 minutes. Probably. So on page 177 and 178, 11 through 17, odds, and 25 to 31, odds.